we're going to look at our four operations: addition, subtraction, multiplication, and division, and some properties of each. First we have addition, and I want to look at addition on the number line, just because it will make it easier when we start negatives if we have already looked at it. I do it a little different from the book. I just go ahead and start at the first number instead of starting at 0. They always start at 0 and move to the first number. But we'll just take a little shortcut. We'll start at the first number, so we're starting at 1. If you add a positive number, you're making it get bigger, so you're going to the right. So we're going to go to the right 3 spaces, 1, 2, 3, and we land at 4, which is good because we know that is the right answer for 1 plus 3. So that is how you add on the number line. Let's go ahead and put some names on these pieces. The numbers that you're adding together are called add-ins. And the answer to an addition problem is called the sum. We're going to look at a couple of special properties of addition. The first is the commutative property, and this property says that we can add two numbers in either order. So we can add 2 plus 3, and it will give us the same answer as 3 plus 2. So the order is not going to matter. We will get the same answer. We also have the associative property for addition, which allows us to regroup if we have more than two numbers. So if we have 2 plus 3 plus 4, we could group it with the first two numbers, or we could group it with the last two. And using parentheses will mean you do that first. So if we group it the first way, 2 plus 3 is 5 plus 4. This gives us 9. If we group the other way, 3 plus 4 is 7. 2 plus 7, it looks different on the line in between, but at the end it is the same. What these two properties allow us to do is to change the order when we add numbers, and this can help us to do things faster. You might have used these properties if you have to add up long columns of numbers, if you can find the numbers that group to give you a 10. It makes it a little faster, and this is why you can do it, because addition is commutative and associative. Next, we'll look at some keywords that mean to do addition. Added to, plus, increased by, more than, total, and sum. Notice the word that's not in the list is the word and. A lot of people think and means to add. And is really a separator, and it can be used with any of the operations, so it doesn't mean add. These are the words that mean to do an addition problem. Next, we'll look at a little application problem for addition, and this one is from geometry. The perimeter of a polygon is the distance around it. And to find it, you add up all the outside edges. So we're going to add these sides. We have 3 plus 4 plus 6 plus 9 plus 8. And I'm going to use my associative law and regroup those. So here is a 10. That makes it easy. 9 and 8 is 17. So 17 and 10 is 27, 28, 29, 30. So it made it a little faster for me to add. So perimeter, distance around an object, add up all the outside edges. The next operation we'll look at is subtraction. And first let's think about commutative and associative properties. Is subtraction commutative? Does it matter which way I write 5 minus 3 or 3 minus 5? It does matter. 5 minus 3 is 2, but if we have 3 and we try to take away 5, we're going in the hole. This gives us -2. We haven't dealt with negative numbers yet, but I think you would understand that one. So these are not the same. This means that subtraction is not commutative. Order is going to matter. So our answer is no. If it's not commutative, it will not be associative. So we'll have to be more careful with subtraction. Next, let's look at some keywords that mean subtraction. So first, of course, the word subtract. The word difference is a very common one. Difference is the answer to a subtraction problem. Less, take away, decreased by, and a couple of expressions. How much more? So how much more does one thing cost than another? Or how much is left? So you paid for tuition, you paid for books, how much is left over for lunch? So all of these expressions that we looked at will translate straight in order when you switch over from words to symbols. We have a couple more to add on to the list, subtracted from and less than. But these two are going to translate backwards, and the order will matter, so you will have to have them backwards. So you will have to be careful with those when you translate. I want to take a minute and look at one subtraction problem. For the subtraction, when we start, we look at 4, and we're trying to take away 9, and we can't do it. We don't have enough. So we're going to have to do what we call borrow. We're going to borrow from this one, and that would leave us 6 in the tens place. We borrowed a 10 to go with the 4, gives us 14. So 14 minus 9 gives us 5. And now we have 6 minus 9, but we can't do that, so we'll have to borrow, which would leave us 5. And we're borrowing 100 out of there, plus the 6 in the 10 spot gives us 160 minus 9, or 90, because it's in the 10 spot. So 16 minus 9 we can work with will give us 7, and then 5 minus 2 will be 3. It doesn't matter if you mark them up the same way I did, as long as you can get to the right answer. What I wanted to remind you about with subtraction is how to do a check. You have to be a little more careful on subtraction, so it might be nice to know how to check. You're going to take the answer, 375, add it back to the number that was subtracted, and it should get us back to the original 674. So 9 plus 5 is 14. There's 10 and 7 is 17. And 5 plus 1 is 6. It does. So we have the correct answer.